Chapter 2, Representing Data Visually. Representing data visually is used in many ways. We can see graphs in the media and professional presentations. It's an easy way to understand data. Frequency tables list classes or categories of values along with the number of occurrences. This means how many times that a number was there. Frequency means how many. Pretend that I survey 10 students in my class. I ask each one, how many kids do you have? And the data as a list are those numbers there. So somebody said 0, another person said 0, and so on. This means 3 students have 0 kids. 4 students said 1 kid. 2 students have 2 kids, and 1 student has 3 kids. And the total is 10 students. So there's the data again, and here's the frequency table. On the left are the answers. Okay, so the students said they had between 0 and 3 kids. The frequency means how many times each number was there. So for 0, the frequency of 3 means 3 students said 0 children. The total of the frequencies should add to the number of people asked. So 3 plus 4 plus 2 plus 1 equals 10 for the 10 people that were asked. Relative frequency. What if I asked somebody what number they were in their class, where they ranked in terms of the rest? The person answered that they were number 9 in their class. Is that good or bad? It depends. It depends on how many people were in their class. 9 out of 250 is good. What if this was a small school and there were 12 people? 9 out of 12 is not as good. It's relative. Relative means relative to the whole. A relative frequency table lists the proportions. Proportions are the decimal equivalent to a percent. You take the frequency and divide by the total number. So we'll use the same data from the first example with our 10 people asked how many kids they had. So for 0 kids, the frequency was 3. And we're going to take 3 and divide by 10 because there were 10 total people. So each of those numbers will divide by 10, which gives us the proportion. The total of the relative frequencies should equal 1 every time because 1 represents one whole. We're finding which portion each one was. So if you add 0.30, 0.40, 0.20, 0.10, that equals 1 for one whole. We can also think of these as a percent. If you convert each of these to a percent, here's the table. To convert something to a percent, move the decimal 2 places to the right. So 0.30, move it to the right 2 times is 30%. Note that the total of the percents adds to 100% because 100% is the whole. We can also do frequency tables using categories. Sometimes data collected has many values. It's easier to group them into categories. For example, Kroger might want to do a study on the ages of people that use their pharmacy. Kroger looks to see the number of people that filled at least 1 prescription last month and then records the ages. You wouldn't want to list all the ages. It would be better to group the ages in categories. This is called a histogram. An example of a histogram. Age 18 to 29. Number of people 235. This means that there were 235 people between the ages of 18 and 29 that filled at least 1 prescription. Okay, so what about the age group of 30 to 39? 428 means there were 428 people in the age group 30 to 39. To change this to a relative frequency table, first we need to find out how many total people there are. This is found by adding up the total in the number column. So add up your total people and you get 3703. So that means there were 3,703 people total. To find the relative frequency table, okay, we're going to take the total, 3703 that we found on the last page, and we're going to take the total number and divide by 3703 every time. Okay, now we're going to also round these numbers to 3 decimal places. So in the middle column, I put a bunch of the decimal places, and we're going to round it to 3 decimals. So let's look at the first one, 0.063462. To round to the third decimal place, look at the third decimal place. That means after the dot. So .063. The 3 is the third place. To the right of it is 4. So that means the 3 is going to stay. Okay, let's find one that rounds up. Look at the age category, 50 to 59. Let's look at its decimal, 0.196867. The third decimal place is the 6.196. To the right of the 6 is an 8, so that 6 needs to go up to a 7. Okay, so if the number to the right is 5 or up, go up. Otherwise, you keep it. Now, one note to be careful about. When you round the numbers, they're not going to add up to exactly 1 most of the time because of your rounding. Okay? If you add up before you round, it will add up to 1. But you might round up or down more, so you won't necessarily have them add up to exactly 1 because of rounding. Okay, bar graphs. Bar graphs are horizontal or vertical representations of frequencies or relative frequencies. This means the height or length represents how many are in the category. Okay, so for example, that graph there, if you look at dining and you go and you see how big it is, it's just a little bit more than 100. So it represents how much. Example of making inferences. An inference is to understand what the graph is about. A sample on taking people's ethical disposition. People were asked their opinion on the morality of a certain situation. Okay, so people were asked and there were 3 answers where it depended, it was wrong, or it was acceptable. Okay, a situation was given and people were asked if it was okay or not okay. What percent thought that it depended on the situation? So let's see how big that bar is for depends, 10%. If there are 315 million people, how many thought it was morally acceptable? Okay, so first, morally acceptable, we need to look at the percent, and we can see it's between 60 and 80, so we'll say 70%. So 70% said morally acceptable, but if we want to know how many, that means we need to find 70% of 315 million. So multiply 0.70 times 315, and we get 220.5. Rounded to the whole is 221. It asks to give your answer in the millions. If someone claimed that 220 million people find it morally acceptable, this would be called inferential statistics because you're making a prediction. We didn't actually survey 221 people. We're making a guess. A Pareto chart is a bar graph from highest to lowest. The largest bar is first and it goes down. Okay, we can see the number of years after release increases for this graph right here. This graph is is about recidivism, which is studying the return of people to prison that have, this means people that went to prison, were released, and then went back. Okay? They went to prison, they were released, but then they did something else and went back to prison. So it's studying people that have been to prison more than once. And at the bottom you have year after release, and at the bar represents percent. Okay, so this is studying the percent of people that return to prison. And what category has the most number? You can see the first year. So the first year is when people are most likely to go back. What about what percent after the third year? So you look, it's between 30 and 40, so 35%. What percent more was the first than the seventh? So that means take the seventh and subtract the first. Now this is a Pareto chart for the most valuable player in baseball. On the bottom, it gives the positions, which the code there is on the right. For example, OF is outfield. 1B is first base. And we can see that the highest is outfield. Why might this graph be misleading? OF, outfield, shows the highest number, but it's a combination of 3 positions: left field, center field, and right field. So this would be more accurate if these were separated. So first base is just 1 position. Third base is also just 1 position. But outfield, OF, is actually 3 different positions. So it would make sense that it's more than others because it's combining 3 different groups. A pie chart shows what percent out of a total each section is. It's useful comparing categories. Okay, so what about this graph right here based on degrees? What percent of people have different degrees? And you can easily look and see what the biggest one is. The largest portion was high school diploma. And you can look to see what the smallest portion is, which is an associate's degree. So it's easy to see how it is relative to the whole. And that's the end of this lesson.